Hello everyone, welcome to Neural with Mohit. Today we are going to learn about rerankers, right? So in our previous video, we learned about VectorDBs and we also learned that how VectorDBs does a similarity search for your query and get the most relevant detail from the document, right? And the document can be anything, we know that, right? So now the question comes is what is reranker and why do we need it, right? So in today's episode, we are going to understand exactly that what are the re-rankers, why do we actually need that, and how do we implement them. So let us jump into the code and understand how re-rankers work, right? So if we will come here on the code and we will try and understand it. So re-rankers are nothing, they are just a relevance model, right? Sorry, they are just a model which is actually used to improve the relevance of your search. Now, if I'll tell you in very layman's style, so it is like your VectorDB does a similarity search, which is done on embeddings, and embeddings are the compressed form of your sentences, right? So when you do a similarity search, it does not get the essence of that complete thing, right? So what it does is it will try and collect the relevant information for you and will bring it to you, right? But from that relevant information, now what you need is you actually want to see that in those query versus results, what actually is more relevant in that, right? So for that, what we do is on top of our vector DBs, we apply a reranker. And what reranker does is it takes the query and then it takes the document and then it will check that, okay, how relevant is this document based on this query, and on that it will assign it a score. So what you will be doing is, let's suppose you extract 20 items from VectorDB, right? So you will give those 20 items to reranker and then you will ask reranker to score them. And maybe from those 20 items you will be selecting the top 5 after the rerankers will give it some scoring. And that is how rerankers actually work. And if a question comes that why do we need reranker, so we will actually understand that at the end of this tutorial, that why do we need rerankers. And this is one of I would say a very important interview question as well, that as you have already done a similarity search on vector dbs and you know that the documents are anyways relevant to your query, then why do you need to add another search on that, similarities search on that, and why do you need to use this particular thing? So let us understand that, right? So let's understand that re-rankers are models used to improve the relevance of search or retrieval results after an initial retrieval from vector db. Let's suppose re-rankers re-evaluate top candidates to sort them more accurately based on original query. So this is exactly what we have just discussed, right? And then there is a reranker versus retriever. So wherever this retrievers is written, this is vector dbs, a reference to vector dbs, right? So retrievers, example vector dbs, quickly return a list of candidates based on similarity in the embedding space. And as I said, embedding space is a compressed state for you, right? Rerankers take the top and retrieved results, which means the result that the vector db has actually retrieved. You will take those and you will rescore them based on deeper semantic alignment with the query. So what it will do is it will not check the embeddings. Rather what it will be doing is it will be checking the sentence to sentence, and it will be checking that how relevant this sentence is based on this particular query, right? So while retrievers are fast and scalable, re-rankers are more accurate but computationally heavier, right? So this is a thing that you do not apply re-rankers to the complete document, rather you apply it to a subset of your query, right? Because they are heavy and they are costly also as well. Okay, so one of the common re-ranker that you actually use is a macro mini lm L6v2 that we actually use here. We will be using a different model but from the same family actually, right? Okay, they consider full interaction between query and document, typically used for reordering top key results. So top key result means the result that you have actually got from the vector dbs. Now you are reordering those results, right? And you might be selecting a subset of that from there. So as you can see, like example, top 100 to top 5, right? So what you are doing is from vector dbs you have said give me top 100 results, right? And here you will be saying, okay, I will collect the top 5 and I will give it, like I will pass it further. Okay. So let's come here, and here we have given some trade-offs as well, like what are the trade-offs between a retriever and a ranker. So in terms of speed, retriever is much faster, we know that, right? It does a similarity search on the embedding space, whereas the reranker will be checking the whole sentence to sentence, right? Accuracy, retriever, we know that it's an approximate nearest neighbor search, right? Whereas reranker actually checks the relevance of the query to the document, right? Okay, scalability, it is very high. Here it is low. So what we do is we actually do not, as I said, like we do not do it on the complete document. Rather, we do it on the results which we have retrieved from the VectorDB, right? And yeah, so contextuality, it is limited, but it is a deep semantic matching. Okay, so deep semantic matching means it actually checks the relevance of the query to the result. Okay, here you will see that the code is, just like the previous video. So we will run through this a bit faster, and then we will understand the re-rankers in more detail, right? So here I am importing the libraries like PDF Plumber, Pandas, NumPy, sentence transformer. You know that we use it, but like last time we have used it for doing the embeddings, right? And this time we will use this sentence transformer library to we'll use this sentence transformers library to actually import the cross-encoder as well, right? Okay, and then cosine similarity, we have seen that when we did embedding and all, we've used it. Okay, persistent client, we use this for ChromaDB, right? So let's come here, and what we are doing is we are loading our document. After this, we will be doing the chunking. We actually understood the chunking strategy in our previous video itself. I will add a description. In the descriptions, I will add a link of the previous video, the previous two videos, basically embedding and VectorDB. I will add both the links in the description, so you can brush up your memory on that. Okay, so here we are doing the chunking, right? As you remember that we did not do like sentence chunking or something. We did a page level chunking, and on the page level chunking, last time what we did is we added a logic that if the number of characters are more than 5,000, in that case we are splitting one page into two. Otherwise, we will be using the same page, right? Okay, so yeah, so this way we will be like creating the document chunks, and once the document chunks are created and like the text content is there, so we will be adding all the chunks to this text content. After this, what we are doing is we are creating a data frame, right? So this is all from the previous video. So I believe if you have seen that video, you must be able to relate it. If you have not seen, I would like advise you to see that video first and then come to this video, so that you will be having a better understanding, right? So here we are creating the data frame, and in the data frame, the document, which page it is, whether there is any split or not, and the content of that document, right? Now from that document we have created a metadata, and you can see this metadata, and we have dropped the other columns, right? So now we have only content and metadata column here. Okay, I have to drop split also. Some of the split is left here. Let me just write split here, so that when I will upload it to GitHub, at least this will also go. Okay, cool. So till here we are done. Now what are we doing over here is we are going to do the embedding here, and we are using the all mini LM L6 v2 model from the sentence transformer Hugging Face sentence transformer library, right? And we will be creating the embeddings of these, right? So here the embeddings are created for each, and here we are creating the IDs. You remember the last time logic, that each ID, what does it contain? It contains the document, name along with the page number and along with the split. So document, page and split, right? Cool. So we'll be creating everything here, and then we will be creating the Chroma store. Now here you can use this directly, get or create collection, but like in the last video I've already created this. So this time what I'm doing is I'm trying to get the collection. If the collection is not there, only in that case I will be creating it and adding the content to it. Otherwise I know that the content is already present in that, so I need not have to add it, right? So in the try you will see that I'm just loading the collection, because in our previous video when I was working on this, I've already added the document to this collection, right? Okay. So now here is how, like, last time we were doing the semantic search. So this on this particular function we'll be doing the semantic search again, right? So this is that thing only where you will be passing the query to the vector DB and it will be checking if the query is already existing in your cache, right? And if the similarity is more than zero point 0.8, in that case what we are doing is we are returning it from the cache, right? So if you will remember this logic, so after adding it, when the query will come, you will embed the query first, right? And after that you will do a search. So in the local cache first you will check if the similarity of that particular query to your items that are present in the local cache, if the similarity is more than 0 point 0.8, in that case we will return it from the cache itself. In case of cache miss, what it will do is it will make a DB call and then it will fetch the top key results, and those top key results it will add in the local cache, right? So same logic here, we'll be checking. In case if it is present, then return from here. If it is not present, then in that case get the results, add those results to your cache and then return, right? Now while returning, you will notice that what I'm doing is I am returning the score as well as I am returning the query that we have found, right? And as well as the result. So I'm returning it as a tuple at this time, right? So you will see if it is not present, then 0 score, whatever my query was, and the result. In case if it is present, then the query that has matched, that query I will be returning, and I will be returning the matched score, and I will be returning the results from the cache itself, right? Okay. So we are making the first query here. Let's see what is Uber's revenue. So what we will get is, it's a tuple, right? So we will get a similarity score. We will get like the retrieval query, and we will get the results over here, right? Like what was the query and what are the results and what was the score here. So we will get all three values in this, and for the first time obviously this line will execute once you have the cached result, and in any case if the result is generated from the cache, then this line will execute, right? Okay, so let's come here. So you will see that I have already got the documents here. So when I did that, what is the Uber's revenue, then I have got all these documents in the result, right? If you want to see the result itself, so we can print the result also. So if you will see the result this time, what I am doing is I am getting top 15 documents, right? So you will be having all these documents here, and you will be having these here, and I have to just make it scrollable. So you will be having the metadata as well in this, along with all the content, right? Okay. So till here it is just a glimpse of what we did in the previous video. Now let us come to the rerankers. So now what we are going to do is we are going to implement the rerankers here. So after you have got the results from your VectorDB, after that what you need to do is you will be creating the rerankers after that. Okay. So for reranker we have different models available, and I have written all the details over here, like what is the speed of that, what is the accuracy of that, and when do you use which one, right? And when to use which reranker, and all these details are actually present over here. So yeah, so we will get this. Now let us come to this reranker caching, right? So what we have over here is a reranker cache over here, which is a dictionary basically, right? And in this dictionary we will be like storing the reranker results as well, because like if the query is very similar to us, right, then we don't need to rerank it again, correct? From the last result only what we have got, we will be putting that. Okay, so a similar kind of logic what we have added for VectorDB, the same logic we will be adding here also, maybe with some different values. So we'll come to that now. Okay, so for this what we are going to do is we are going to use the Cross-Encoder. Okay, so you must have seen over here we are using these, and see this Cross-Encoder models are here, right? So we are going to use in this, I think we have so we'll be using the L12 model, right? In this you will see that I have used the L12 model. You can use any of the models basically from these, but yeah, for this I am using this. Since I'm using the Cross-Encoder, I could have used any of these models. I have chosen this one because it has a high accuracy, but the trade-off is it is slow, right? You could have used this one as well, which would have been having a like very high speed and medium accuracy, right? Since it is a very small set, so I decided to use this one. As you notice that we extracted only 15 values, right? When you have like 100 200 values, then it becomes a bit slower, but 15 values is very small to work with. Okay, so let's come what we are doing here. Let's see. Here the similarity score is the result that we have received here. So similarity score, retrieve query and result. So these three variables we just have to remember because we are going to use it later, right? So here what I am doing is the similarity score, if it is more than 0.9, in that case what I am doing is I am getting the return query from my rerank cache, right? So there if you remember I did more than 0.8. Here I am doing it, I'm making it a bit more strict. I am checking it only for the queries which are more than 0.9, right? Okay, and reranker returning from cache for query. This is the statement I'm printing so that you will know that for this query you have got the results. Okay, and these are the results that will go. If this condition does not satisfy, in that case what will happen is we will create the model, we will initialize a reranker model. Then what we will do is we'll create the pairs, right? So in pairs what we are doing is the query that user has asked plus the document that we have created. So that document we will be sending. Now what is this document? This document is the result that you have received here. So if you remember like this, right? So these are the documents, all the documents. So what we are doing is for each we are sending query document, query document, query document, query document. So like this each will be having a pair in it, right? So here we are making that pair. So it's a tuple, if you see, it's a query and document tuple, right? And after this what we have to do, we will be sending it to the reranker model and we will be asking it to predict. So as I said that the reranker model actually compares your query and the relevance of the document and then provides a score to it, right? So what you will receive in return is a score from the reranker model. So you can see that the scored results are here, right? Once we receive the scored results, then what we are doing is we are actually sorting those scored results again. First let's see this. Yeah, so once we have received the scored results, then what we are doing is we are zipping the scored results with our documents, right? Here you can actually zip it along with metadatas also, but I have to create, get the metadata, like I decided to get it like add it over here, but now when I see this code I can say that I could have added this here as well in the zip itself. Okay, okay, fine. So till here we are done because the indexing here does not change, right? So metadata will also having the same indexing, so you can zip it with these three items. Okay, cool. So we are done till here. Now the new docs that we have created, this actually contains three items. Okay, first item will be doc, which is the content basically. Second item will be the metadata. Metadata is something which contains which page it is, which split it is, kind of, right? And third is the score for that. And what we are now going to do is we are going to sort it based on the scores. So here if you will see, I am saying that sort these items. What do I want to sort? I want to sort this and based on the third element, right? So first, second, third. So based on the score I'm going to sort it, and I'm saying reverse true. So that means I'm going to sort it in descending order. Okay, and then from the sorted results what I'm doing is I'm picking the top 5. So from VectorDB I have got top 15 results. From those top 15 results what I'm doing is I'm selecting top 5 of those. So now these top 5 are actually based on the relevance score given by the reranker, right? And these top 5 are now actually returned to you. Okay, and before returning what we are doing is we are storing it in the reranker cache also, so that next time if a query comes which has a similarity score of more than 0.9, so in that case I will get it from there. Okay, so now let's come here. We have the query. So what we will do is we will simply run it. Query, you remember that it was here itself. This one, what is Uber's revenue? This was our query. So I'm going to hit this on the reranker. For the first time, obviously there are no results. So what will happen is it will create the model and it will do this complete exercise, right? And you will get the results over here. Okay. And if you see the results, so you can see the score with each result. That here is the score. This is the document. I'm printing just first 1,000 characters, right? And this is the page of that. So if I'll make it scrollable, so in that case you can see that the top 5 elements, like this is the second having this much of score, and this is the page number, and this is the content, what is Uber's revenue, right? This is the third with this, and then page number this, and then the content this, right? So this you can see like this. All the documents are like right now, scored based on the relevance, and they are sorted also based on the relevance, correct? Okay, so now let us do one more exercise of this. We will hit the query again. Last time we have asked that what is Uber's revenue. This time I have intentionally asked what is the revenue of Uber, right? So if you'll see, the question are like exactly same, right? So my expectation here also is that my relevance score should be high. Not relevance, my similarity score should be high there. And from the VectorDB, the similarity score that I will get, that similarity score I'm going to check in my reranker. If the value is more than 0.9, then I will not be initializing the model and all again. I will be returning from the cache, because we have done, like last time only we were able to like when we did the model and the relevance and everything. So we have stored the result in our reranker cache, right? So here first we will hit the VectorDB. What is the relevance? What is the revenue of Uber? Okay, and let's set a question mark here. Yeah. So what is the revenue of Uber? It will do the similarity score. It will do it will give you the return query, and it will give you the results. Okay, these results will be 15 because we have asked for top 15, so it will be 15 or less basically for you, right? And now after this result is received, then what we will be doing is we will be re-ranking it again. So in case of re-ranking, if the similarity score is more than 0.8, then we will not initialize the model, rather we will return it from the reranker itself, right? And how do we know it is returned from the reranker? Because I am printing this statement over there, right? Okay, so now let's see. So when we will run this, so what you can see is we will get this result, returning query what's Uber revenue from cache with a similarity score of 0.9791, right? This is from the VectorDB, and you can see the similarity score is very high, because if you see these queries, they are like almost same, right? And you see reranker returning from cache for query what's Uber's revenue, right? So instead of this query, we are actually returning from this query, right? And you can see the same result being returned to you. Okay, so now since you have understood, let's now discuss why do we need rerankers. As I said that we'll discuss it in the end, and this is one of the interview question as well, where the interviewer may ask you that since you have already got the results from VectorDB, why do you need to add a reranker as well, right? Because it will add cost, it will add latency, and like the result anyways you are having, so why not pick the top 5 from the VectorDB results only and give it back, right? So the reason for that is VectorDB search is actually on the embedding vectors, right? So it does a semantic search on the embedding space, which is a compressed form of your word. So which means like it actually does not contain the exact word, rather it somehow maintains the similarity of that and creates a similarity vector and then stores it in the embedding space. Okay, but when you do a reranker, so what reranker model does is it takes the query, it takes the document, and it will see how relevant is this document as per this query, and based on the relevance it will give it a score, right? So that is where the re-rankers actually shine, right? But this is where it becomes costly also, and this is where it becomes slow as well, right? So what we, as I said in the beginning, you should not use the re-rankers for searching on the complete document. Rather, the approach is always search via VectorDB, get the results and get more number of results, more than what you need, right? You can get 10 times more of what you need. Let's suppose I need only 5 results, I might be getting 50 from there, or I might be getting 100 from VectorDB search, right? And after that, what you can do is you can actually run a re-ranker on top of that, and then store those sort those results and pick the top y elements, whatever you need, pick the top y from there, right? And uh, when you are doing this particular thing, right, so what will happen is you will get some extra cost on the re-ranker, but actually the output that you are going to generate, that will be much more accurate and much more relevant to users query, right? Okay, so we have discussed everything. Now from the application, let us quickly discuss how the application was working, and with that, so that we'll be having a complete idea of how the application actually uh, uh, was working here. So when we get the document, so what we will be doing is, first we are creating the embedding using the embedding model, then those embeddings are stored in the VectorDB, right? So this is the place where the Uber PDF, the Uber's revenue PDF, we actually stored in the VectorDB. Since we have done it in the last video, when we were doing in the last exercise, there we have done that. So this time our VectorDB was already having that, right? Because I used a persistent client, which means the embeddings were stored on my the vector DB was stored on my disk, right? So I was able to load it from the disk itself. Okay, now when the query comes, you remember in the last time I told you the embedding model that you use to create the embeddings to store in VectorDB, the same embedding model you should be using to create the embeddings for query search also, right? So you'll be using the same model, creating the embeddings, searching in the local cache first. If we get a result with similarity score more than 0.8, in that case we are considering that as cache hit, and in that case those top key results will be sent to reranker, right? And the reranker will again like the return query will again be sent to reranker cache first, and we will be checking if the query to query similarity score is more than 0.9. In that case only we are returning it from the cache, otherwise it will be going to the reranker model. The model will be creating the top 5 queries, and then we'll be storing those to the reranker cache, right? And from there we will be returning the top 5 results. In case it is not present in local cache, VectorDB local cache, then it will go to VectorDB. It will extract the top key results. It will store it in local cache of VectorDB. Then from that we will be sending it to the reranker, right? Since it is not present here, so definitely it is not present here also, right? So here in this case of cache miss, the flow will be directly like here to here to here to here. Okay, so you will be going to get the top key results from here. The top key results will be sending to reranker. The reranker will be running the relevance on this, and then it will be extracting the top 5 re-ranked results from here, storing it in the cache of the rerank, and then returning you the response. So this is how the whole system at this point is working, right? So we are very close to make the RAG application, and now the only part which is remaining in the RAG is adding an LLM. So we are actually we have completed almost everything else to create a very basic RAG application. Okay, so yeah, so this is all for the re-rankers today. If you have liked it, I would ask you to like it on YouTube as well. Share it with your friends so that they understand the nuances of re-ranker, VectorDB, why they are used in the industries, right? And also subscribe to the channel. Thank you.